Hello everyone, welcome back to my YouTube channel. So in this video, we'll see how to complete this extra activity 4 for this stats 2. Uh, I was planning to make a video on this, but I was not getting time because for this Margali event, there are so many this event proposals coming in, and the sports department are conducting interviews. So I was busy with the sports department and this interview thing. So I was not getting time. Like I have to complete my activity also. The deadline is near. Let's see the activity. Okay, this is the extra activity. This thing we have already done in the stats one, activity four. So you can check that also. Basically, how you can access the courses. You can go to this part, this completed. Here you will find a statistics one. Click on it, and you can go to here. You can click on this, go to course page. Okay, so it will say you are not subscribed to this course. So here you will have to just log out and you will have to log in with your previous ID, previous email ID that you have registered. Once you log in with your previous ID, you will be able to access this stats one course. Okay. So you can check that. And the reason I'm saying this is because this is the same activity that was present in this stats one course also. So you can check there also what you have done over there. You can take some hint from that there also. Basically, most of the student over there used this discrete part, discrete thing, and mostly Poisson's distribution was used over there. Even I remember correctly, if I remember correctly, I used that only. But now that we have learned some continuous thing also, so we will experiment more with this continuous part. So there is no restriction, like we have to use discrete or continuous. We can use anything. So here it is given the example for the both cases. So you can remember this one. So this was the IPL power play data set that was provided to us in the this is stats one also, same thing. Just this is the extra continuous thing. This is the something new that they have provided, and they have also given this Excel sheet. The reason I'm showing you these things because when I will explain where my model fail, you will these things I will take the reference of these things. Okay, so so for my activity, what I did was took two data. First data was Indian GDP, and second data was the Google profit. Okay, the quarter-wise profit of the Google that they made in each term, in each quarter from 2009 to 2024 till now. So here you can see that data is from 821. So you will not find any company whose data is available this like this long back. It's not basically possible. There was the digital digitalization of data. Okay, the data that started getting uploaded on internet. It basically started after 2005 6. So uh, before that, most of the data and the profit were handled on the paper only. So I don't think like this is even a genuine data. They have just randomly assigned a value over there. So we cannot use this one definitely. So for Indian GDP. Okay, so this was my very first data that I collected. What I thought of working on this was I thought that maybe we can observe some trend. Like you can see the Indian GDP is constantly growing. So I thought like maybe we can do some exponential distribution over here, which can like help us to predict the GDP of the country. Like say this is 2023. What will be the GDP of this country in 2025 or 2026? So that was my primary understanding on using this data. So we can model something and then we can do some prediction. But when I presented this data in front of Bhaskaran sir, he completely rejected this, said that you cannot model anything based on this data. And the main reason is the GDP standalone does not depend on one parameter. Okay, there are multiple parameters that contributes to the GDP. And let's suppose population growth is one of the parameters. If suppose there is a war going on, that will affect the GDP. So there are like 700 or more than that. There are multiple parameters that are involved when you try to make a model of this GDP. So he said that it's not going to work. So if you want to model the GDP data, you will have to model all those possible things that contributes to this GDP. Okay, that was the reason this model, this data didn't work. So I took some other data, like I was having this Google data. Okay, here we can learn something. Okay, this even directly, even this data didn't work on the I was not able to properly model this data, but still I will tell you where I failed in modeling thing. Okay, so this is the data. This was the thing that I was explaining. This term by term, I have taken the profit. Okay, I found the profit somewhere in some macro trends. If I remember correct, the website name macro trends. There I got this data. From there, I just copied this data, and then what I did was I created this bins. Okay, this intervals 0 to 5,000, then 5,000 to 10,000. I created an interval like this. Then the I just sorted the frequency that between 0 to 5,000, how many times the profit was between 0 to 5,000. So there was seven times. 5,000 to 10,000, there was 16 times the profit lied between 5,000 to 7,000. And then between 10,000 15,000, there were 9 times the profit was between 10,000 and 15,000. So I sorted out this data, and when how can verify that whether this sorting is correct or not? If you add these all things, you will get the final answer as 63. So you can see these two rows, this row and this row. If you minus this two row with the entire data, so there are 65 data. If you minus it with 65 minus 2 is 63. That means my all frequency, the 63, this value is covering my entire data. Okay, so we did the same thing over here, found the probability. So how I can provide this probability is nothing but relative frequency only. We have studied these things in stats 1 in qualifier. So here just simply take this you can see this F4 7 divided by 63. This gives you this part. Similarly you can do for this one also. Similarly I did for this also, and then I use the formula for this exponential. Okay, this lambda times e exponential e raised to minus lambda x. Okay, and from there I calculated this exponential part, and then I added this entire thing, and it came out to be 0.002. You see the probability over here is coming exactly 1, because this is a relative frequency, and relative frequency always add up to 1. You see the probability that I'm getting over here. It is not even 0%. Okay, and Bhaskaran sir said that if the probability is not coming to be 0.1, it's not even 0.1, we cannot use even this model on this data. Okay, because the probability is very less. What is probability? Probability is basically a measure of some uncertain thing. And if it is not even 0.1%, then what is the use to measure that event or anything? You can say this was the things sir explained me, and sir said that you cannot even use directly exponential over here. So then we moved on to, then sir asked me that okay, check for binomial. The reason binomial is also not going to work over here, still sir said that okay, we know that it's not going to work, still check that where this thing contradicts, and the thing contradicts over here. You can see this is a mean which is around 9,343, and this is the variance. So Rahul calculated the probability. You can see we have this NP, and then this NP times 1 minus P. Okay, so from these two things we calculate, Rahul calculated this value of P, and that value of P came out to be negative, and we know that probability is never negative. Okay, so from there it was clear that okay, even this binomial is not going to work for this data. Okay, so Bhaskaran sir then said that we cannot directly make any trend out of this profit, because this profit is constantly increasing. If you see from this 2009, you see the data, it is constantly increasing. Okay, so Bhaskaran sir said that what we can do over here is we can find error. Okay, the profit that we are calculating, the profit that is being displayed, what is the error that can be present over there? So basically these all the things where we did all the rough works over here, and we tried to sort out something that we can model it. So this is the profit error that we came across. So I will tell you how to calculate these errors and estimated errors, and this was the final, this probability density curve, some sort of normal distribution curve we got over here, and then we came on a conclusion that okay, not exactly. You can see over here, this is the normal distribution that we calculated, and this is the probability, that theoretical probability that we calculated for initially. So you can see the values are not exactly same. The values are very much different, but still we got a curve like this. So we can say that okay, normal distribution is somewhat fitting this data. Okay, so this was an overview on this thing. Okay, now over here. So this is the profit data and everything over here. If you want, I will share this data with you, but I will suggest you to use some different company. There are a lot of companies over there. You can use any of this thing. So what very first thing we are going to do is we will plot a line graph. See, suppose total number of quadrant. How do we find this total number of quarters? This is the first. Okay, we started from 2009, 331. Okay, so in a year there are 4 quarters. Okay, there are 12 months. Each month is so entire year is divided into 4 parts. Okay, each quarter is of 3 months. So this March one is first, then this 6 is like June, and then there is June, July, August, September, and then there is this December. So 4 quarters are there in one year. So this became our first quarter, this became our second quarter, this third and fourth. So similarly, we had our like 63 quarters. Okay. And for this 63 quarters, we have our profits. Okay. So what we'll do is we will take profits on y-axis and we will take quarters on x-axis, and then we will try to plot a line graph. Okay. This vital go up, insert. See, the reason I'm telling you because these things are not taught in the class, and these things are important. Okay. We need to model a data. Even I was not very much expert in these things. Bhaskaran sir really helped me. I got stuck with how to do this, and even then Rahul also joined in, and we had a pretty great discussion on how to model a data. If suppose a data like this is presented in front of you, what is the use of this data? What type of thing can you predict out of it? Okay, so that is the main point of being a data scientist. So like I'm not an expert in this, but okay, we can make use of this also. So this is thing, we can customize this chart a little bit. Maybe I'll use this light yellow color and this theme font. I love this font, this series. And then in this series, so how you can find the equation of this line. You can see this trend line over here. Okay. So if you click on this, it will show you a line. This is the trend line. This is the same thing we did in the, okay, I will tell that also. And this for trend line, if you go over here, this is your R square. And in this custom level, you can use the equation. Now this shows you the equation of the this line. Okay. And you can just remove this R square, not required. Okay. So this is the same thing we did in our maths thing in qualifier. Okay. It was, I think, in week 2, the SSC that we found over there. And that was the basically same thing we are going to do over here also. So this is the line, this line, and this is our equation of the line. So we can just write it like this: y equals to 733x minus 4124. So basically that will give us that 733 as a slope. It's not exactly like that line, but just understanding. And minus 4124 as a y coordinate. Okay. We can use a formula also. I don't know what the formula was. Okay, this is the formula. Linest C3 665. So from here to entire this is your y column, and B3 to B65. This is your x axis. Okay, this is your y axis, profit one, and quarters are your x axis. So you can use the formula directly, and it will give you the same value. This basically in layman terms, we can say it is a slope, and this is as a like a y-intercept. Okay, so you can see the same values in the graph also. This is minus 4124, and this is 733. So 733 minus 4124. So we got the same value. Okay, let's put this aside. So now what we are going to do is we have this equation. Okay, these profits are our actual profit. Now we have to calculate a estimated profit. Estimated profit. So how we are going to calculate our estimated profit is, you see this equation. use 733 multiplied by x minus 4124. This is the equation of this line. Okay. So for every x, these all values are our x-axis. Okay, lies on the x-axis. So we keep on substitution. So we will substitute the value of x 1, 2, 3, and we will get a value of y that will be on this line. Okay, and that will be our estimated value. So I will write the formula over here. 733 multiplied by x plus minus 4124, and then I will just do this one. Okay, so this is our estimated profit. Okay, again, cross check. Estimated profit is same. Here basically we use different this cell 72526511924 This is correct. And now for this part we will find the error. So how we're going to find the error is, it is basically giving also this actual profit minus this estimated one. Okay, so here you got this one. I will drag this down till here. Okay. Now you see, this is the error we got. Okay. You see some of the errors are in negative. We don't want negative errors. The reason is I'll give you a very simple reason. Suppose you are having an error over here. Suppose this is a point, and I draw a point, mark a point. Like I don't have anything to mark it over here. Suppose this is this point, and from here to this line, the distance is 2. Okay. And whatever the distance is, basically that's the error. And suppose from here to this line, the distance is -2. Then if you add these two errors, this -2 and +2, it becomes 0. Okay, that 0 does not mean that there is no error. There is error, but as the magnitude are in different directions, it is canceling out. So we don't want to cancel out those errors. So for that only, we take a absolute value of the error so that it always stays in positive. Value always stays positive. So we will do absolute value of this one. Okay. And now you can see all the values became positive. Okay. So here also we had only positive values. Now what we will do is, and the reason like this is showing a complete value what it is, because you see they have in this equation they have ignored the decimal part, but here they have included the decimal also. So there is a little bit of like not perfect, I would say, but we can continue. This R square we don't need this one. So from here, now what sir explained me to do was to make bins. So we made a bins like this. So we made an interval of the error. This was the error that we found. Now we are going to work on this error, okay? Because we were not able to make any model out of this profit data. So we calculated the estimated profit and we calculated the error. And now we will model something on this error. Okay, we'll try to find a trend line in this error, and then we will make a claim. Then we can make a claim. Okay, suppose in future in 2025, I make a prediction that Google is going to have a say profit of 55,000 seven 55,000 dollars, 55,000 million dollars. Okay, so in that, what can be the possible errors? Okay, either it will be more than the expected profit, or it will be less than the expected profit. So there we can model this data. So we can take intervals also. So we will start with 0, then the next interval will be 1,000, will be 2,000. Okay, so we will make an interval till 10,000. Okay, now we'll find the frequency. So in dollar signs, change. Okay, so now we have created intervals 0 to 1000, 1000 to 2000, 2000 to 3000. Okay, so from now here we will use the frequency. Okay, so what is the data? Data is this our errors. So we can copy this one, and then our classes is this one 0 to 1000. We will do this. Let me just verify it. So 1000 is 6. The data has been moved slightly down. So just a minute. Frequency data is from here to here. Then interval is from here to here. Okay, now it's correct. That's coming in numbers and numbers. And, so we got the frequency. Let's remove this part. What happened to this one? Okay, just ignore it. We will take the sum of all the cells. So from here to here. So you can see it is coming to be 63. It is coming to be 63, and we exactly have this 63 quarters. Okay, we exactly have the 63 quarters. Now here we will find the probability. So that okay. So probability, what we are going to do is you just take equals to this frequency divide by this total frequency. This is 0, and we will okay. Here we will have to make it constant. F4. Okay, now this is fixed. Now we got it. Don't want this data. Okay, sorry. And then we'll drag it. Yeah. Oh, now it's done. We got a this probability, and now what we can do is, so this is the probability we got. Okay, so in this activity thing, extra activity, what over here you are going to do is this much will remain the same, error in the quarter. This formula will just change. You can simply use the this HTML code, or you can display in HTML viewers. There you can just change. The only thing that will change over here is total number of quarter where errors. This profit will change into error, because the model that the work I created was on profit. Later, sir told that okay, your profit thing is not working. So we model, we found the error from it, and then we model our this entire activity on errors only. Okay, so the here errors will come where the errors is less than or equals to a, and what will be your a? A will be your the value of all this intervals 0, 1000, 2000, and 3000 like this, and uh, okay. So and your so here you will come like f of 0. You will put this probability 0. Similarly, here you will put f of 1000, f of 1000, and the probability over here will be this one. For 1000 is this one. So just cancel this one. Put like this. Similarly, you will do for all this till 1 till 10,000. Okay? So this will complete your this part. Okay, this will complete your this part. Now you will move to another, that calculating probability using exponential. This exponential not, it will be your this say normal distribution. Normal distribution. Okay, so we don't have to use anything like I did it like earlier. So what you can do over here is you can just mm, here if you are willing, you can put this graph. If you are interested, like you want to explain something like on this graph, that how did you come up with this, so you can use this plot over here, display it over here, and then you can explain that okay, fine, from here I came to know that okay, the correlation coefficient is this one, the constant value is this, and using that, yeah, I calculated the estimated this profit, and then there from the estimated profit I calculated the error. Then I clubbed the error into intervals. From the intervals I calculated the frequency, and from frequency I calculated the probability. Okay, so now I will calculate the normal distribution. Distribution. Okay. change it. Formula will be over here, normal uh, distribution. This x is going to be the intervals. Okay, so this will be, and then the mean of this data. Okay, so the mean of this data we will have to calculate. Okay, I have done also over here this mean of the data. I have calculated over here, but I will explain you how we can use the calculate the mean. Just e, and e 22. Okay, so I will just explain you how we can calculate the mean and the standard deviation for a grouped data. Okay? So this is our grouped data. We just need this part. So we'll just copy it and we can paste it over here. Now we'll work on this only. How we can. This is a group data. Okay, this is a group data. Now we have to calculate the this mean of this one, then variance, and then we will have to calculate the standard deviation from there. So how we are going to calculate? We have already done this thing in our stats 1 course in the qualifier, but we will see over here also. So first thing we'll do is we'll find the midpoints. Okay, so midpoints equals to this the here this column, the first interval. This is the first. This is 0, 1000 is an interval. Okay, and we need to find the midpoint of that interval. So we'll just add this one 0 plus this 1000 divide by 2. This will give us 500, and we will do the same thing. This is not required. The frequency is 0. Don't know why the frequency is getting 0. Now it's good. Now we can. So this is our midpoint, and now once we have find the midpoint, we'll calculate this midpoint multiply by frequency. Okay, so what we will do is equals to this 500 multiplied by this frequency. This will complete our this part, and similarly what we will do is frequency, and we'll have to add this one also. So here equals to sum this part 63. Then we will have to take just mean frequency, and then we divide it. Okay. Then we will have to take the sum of this part equals to sum. So midpoint multiplied by frequency, and then mean minus frequency. Okay. So over here we'll just find the mean. So mean will be nothing but equals to this 25 fixes this one, divide by this 63 will fix this one, like 4073 will drag it down till here. Okay, now for this part we will the midpoint multiply by frequency, we name it like m. Okay, so we will name it like m. Let me just change it now we'll do is m minus mean. We'll do it m minus mean, so equals to m is our this one minus mean is our q2 minus q1. Okay, so we'll fix this one also. We will fix this one. This is fixed, and we got this mean. Okay, now what we'll do is m minus mean whole square. So the reason we did square over here is you can see there is a minus over here. So we don't want minus sign. So equals to this multiply by this. We got a mean. Now we will add this one equals to sum q2 to q1. So we got this one. Now we will find the variance. So we will find the variance equals to what we'll do is we'll take this value divide by the 63, 12,000 and then we'll find the standard deviation. The standard deviation equals to standard deviation equals to SQRT square root of this value. So it just gives us our 11.0. Okay. Now that we have our mean, this you can see the mean is 40007, and our standard deviation is 11301. Okay. Now we can find the normal distribution equals to normal norm distribution. X, our X will be this 1000. Mean will be this part, this one. Okay, we'll need to fix this mean. Okay, and we will take standard deviation. Standard deviation is our this one. We will again fix this standard deviation. For to fix this standard anything like this dollar sign, you need to press this F4. Okay, now you are done. And this for cumulative, we will use true. Sir initially told that. Okay, so I will just drag it down. Initially, I took the value false, and the value was really absurd. So I will like copy this one, and I will paste it over here. So here I will just change the value to true, false. Okay, let's see false. Don't want to copy it. And see the value. Just see the value. This is our probability that we calculated. Look at the probability that difference that we are having. It is nearly zero, and this is basically we're close to this one, somewhat, not exactly like this is not a proper modeling that we have done over here, but still, okay, the model itself is not correct, but somewhat we have tried to figure out, okay, the error, and we have on the error we have tried to uh, put a normal distribution to like check whether, okay, what type of thing can we expect. So we so so for this probability also we can plot a graph. We can see chart. We can make it as well. So this is some sort of a bell shaped curve what we are talking about. And you see this normal distribution, this will not give a bell shaped curve because this is like create insert chart. You see, even if I change it to bell shape, it is giving a straight line. Okay. So the reason is this model is not perfectly 100% fine. We're just trying to estimate something, we're trying to make sense out of nothing. Basically, this is what I will put entire thing into. Uh, how is this model going to work? Basically, it will help to predict the errors while we are like predicting the profit in future. So it will just we can account some error, but still these errors are not accurate in itself. Okay, this is my activity, so this is a very small data I have considered. So this is the reason not perfectly we are getting this straight line, and for the other probability we are getting this bell-shaped curve. So I mean somewhere we can use it, this thing. Just I'm trying to model something and complete my activity. That's the very first thing. So this much is done. Okay. So for the probability part, you are going to copy the values from this thing, and for this down part from here, you will copy the value from this normal distribution thing, and then you can make a conclusion that okay, the approximate, we can just write it down that okay, the values are not very accurate because calculating error for a profit for this thing is not 100% accurate. But still we can model a data where we can estimate some sort of error, and that using that error we can predict some profit in for the future. Okay, so this is type of modeling that we can do over here. So I will just from here only I will just put it everything just over here, and I will just attach all these things. Okay. So the informations I will these two is probability distribution, normal distribution. These information I will use to like complete this Google Doc. And what I will do is I will just redesign this entire thing properly. Maybe I can make some extra sheet also, and there I can explain this a little bit more about this thing, and will just attach this sheet into my Google Drive, this Google Sheet, Google site. So this is it for this activity. So I will suggest you, if you have any data and you don't know how to model these data, you want to learn more about this, you can get in contact with Bhaskaran sir. He will teach you on how you can this model data. See, the very first thing is we are going to become a data scientist. If we don't know what to do with the data, what's the use of this course then? And this is the thing that Bhaskaran sir told me also. So I'm just forwarding his message to you all. Learn to model data, play with this Google sheet, and yeah, if you have some sort of data, you can think it will be good that we will you can work on it. And if you are not able to find any model for it, just get in contact with me, or you can join the group. There I keep on posting things, saying even if you want, I will provide you the contact of Bhaskaran sir. You can get in touch with him. You can like take one-on-one session with him, and there he will explain you how to model these type of data. Okay, what type of modeling you can do on it. Okay, so this is it for this activity. So I know most of you will struggle with these parts. So what I will do is I will on my blog I will just mention on how you can calculate. You can like finish this activity. I will mention some of the informations over there. Still, I will suggest you. Suppose I use the alphabet data over here. I will suggest you to use some other data. Okay, some other company's data you can use, and you can use the same model, and you can just complete your activity. So there also I will plot put these graphs and everything on the blog. See, I will not see. I will not encourage you to just copy paste this activity. Okay, this is of course we are supposed to do it by our own, but still you can take help from here on how things can be modeled. You see that I started with this one, this profit thing, and we checked that these two distributions are not going to work. So we thought that what else we can do on this data. Okay, so this was not my idea actually. Bhaskaran sir was like guiding me all through all this discussion and everything. He said that okay, what we can do is we can estimate the error, okay, while calculating the probability, this profit, and then for that error we can find the probability, and then we can use a distribution to claim that okay, the probability is valid. Okay. So this was the primary intention of doing this. You can see here also the bell-shaped curve was there. So this is the thing for this activity. I will provide every single detail on my blog. Uh, you can just use these informations to complete your activity. And even if you're not sure, so you must have completed this activity in your Stats 1 course. So you can take the help from there also, and you can complete this activity. So just the main focus for this activity is how we are modeling a data. Okay. So even I'm not like very much good with it. This I'm still learning. So that's it for this video. I will try my best to provide all these informations on my blog, from where you can just use this data and complete your own activity. Okay. So this is it for this video. Uh, Thank you for watching the video. If you like the video, please share, and subscribe. And also, this the Leo sir has joined us, and he's in currently BSc. Okay, so he will be posting this Python videos and everything. We have this Bhaskaran sir who will manage the statistics on all. For maths, I'm not getting time to upload videos for mathematics, but I will see maybe today is the deadline for the graded assignment. What can we do for this math thing? So stay tuned for any update. And if you want to get in touch with any of the teachers or Bhaskaran sir, so you can join the group, and we can stay together. So thank you for watching the video. Bye. Let me close this one.